Welcome to this short video preparing us to prove the Pythagorean theorem. Simply put, we need to show the sum of the squares of the legs of a right triangle equals the square of the hypotenuse. Now, because the theorem involves squaring, in other words, a multiplicative function, we need to look for similar triangles, because similar triangles allow us to form equations involving proportions. And proportions will lead to multiplication. Unfortunately, we only have one triangle. Grrr. So, when your back's against the wall, we introduce an auxiliary line. And we can be clever since we're dealing with a right triangle. Let's make sure that we're drawing in a segment that is perpendicular by design. So, now we've created two smaller triangles. And altogether we have three right triangles. And let's color all the angles that we can see. In addition to those angles, let's label every segment that we can see. And let's break apart the triangles to better analyze the situation. Focusing for a moment on the angles in the middle triangle, we can deduce that the third angle must be red. How do we know that? Looking at the triangle on the right, what must the color be for the third angle? Of course, it must be blue. So here's all the information that we can mark and color for the three triangles. To make our work a little bit easier, let's reorient the smallest triangle, flipping it up and then turning the triangle. And let's reorient the middle triangle, flipping and turning. And now we should start looking for equations. The first we might consider would be that C equals C sub 1 plus C sub 2. What are some other equations that we can write, knowing that we have several different sets of similar triangles? Once you have all of those equations written, try to take all of those equations and use algebra to get down to one equation, namely a squared plus b squared equals c squared. Good luck!